Number 10, the function f of x equals negative 2x minus 5 is shifted 2 units up. Which equation correctly describes the new function? So right here we're given an original function, f of x, and this is the equation of that right here, negative 2x minus 5. And then our instructions say that we're going to shift that 2 units up. If you come over to this chart of transformations and function rules, you see that shifting up a certain number of units means you add that certain number to the end of the function. So I see that 2 units up means I'm going to be adding 2 on the end of my function. So you'll need to take your original part right here, negative 2x minus 5, and then add 2 to the end of that. After you combine your like terms, you should have your new function. Number 11, which statement best describes how the graph of g of x equals negative 5x squared compares to the graph of f of x equals x squared? I have 2 pieces underlined here for you, the negative and the 5. Those are 2 differences when I'm comparing to my original function over here. This negative is doing something to my graph, and multiplying by this 5 is also doing something to my graph. If you jump down here to our chart of function rules and transformations, we can kind of see which ones match what we've got going on. This last column right here might be helpful to you. I do have a negative multiplied out in the front of my x squared, and I also have just some actual whole number, in this case it's a 5, being multiplied up in the front of my x squared as well. So 2 separate changes. I underlined the 2 separate pieces here, and that corresponds to 2 different transformations in this table. So I see that this one, multiplying by that negative, is going to be a reflection over the x-axis. And then I see that multiplying by that 5, since 5 is greater than 1, that's why this one is selected right here, that's going to be called a vertical stretch. So you'll need to find the answer choice that corresponds to the changes that are happening in g of x. Number 12, which function shows the function f of x equals 3 to the power of x being translated 5 units to the right? So again, we have an original function, f of x, and then it tells us that we want to translate 5 units to the right. If I jump down to my table, I see that moving to the right a certain number of units means I subtract that number right next to x. It's a change that happens with my variable, with my input. I'm not subtracting at the end of the equation. I'm not doing anything up in the front of the equation. It's happening with that input variable. So I know that that minus h is going to come with the x. So 5 units to the right means I'm going to do a minus 5, but it's going to be inside the, like kind of sitting up where the x is. 5 units to the right is going to change my exponent right here. And the last one, number 13, the function f of x is graphed below. This is your original function. And your instructions say which graph shows f of x plus 2. So again, I'm going to jump down to my chart and just see what this question's really asking me to find. When I have a plus 2 hanging at the end of my function, at the end of my equation, that relates to this first one right here in the list. That means I'm shifting up that number of units. So in this case, I'm moving up 2 units from where I started. So you need to find the graph that looks like this one. The only thing that's going to be different is we move it up 2 units. Now I want to point out one of the important features of this exponential graph. You see the dotted line right here? That's called an asymptote. That asymptote is a really easy way for you to see where your graph is shifting up or down. So right now, currently, my graph has an asymptote at positive 1. If I shift this whole graph up 2 spaces, I'm going to have a brand new asymptote at 2 units higher than this level. So take this dotted line and bump it up 1, 2 spaces. And right here where I'm hovering, that's where you should have your asymptote of your transformed graph.